right, let's get started. Welcome back, everyone. Our next workshop is a demo on the Fiddler AI Observability platform for ML and LLM ops, co-presented by Sabina, Cartacio, staff product manager, and Barun, Halder, staff software engineer. We will have a few polls throughout this workshop, so please answer the polls. If you have any questions or comments throughout the workshop, please put them on the chat or Q&A section, and we'll address them. Over to you, Sabina.
Awesome. Thank you, Karen. So I'll go ahead and share my screen here. Into slideshow. Okay, great. Well, hello, everyone. Thank you for coming to our session. Before we jump into some really cool demos, I'm going to start by giving an overview of what the Fiddler AI Observability platform offers for your ML machine learning model processes. So before I jump into it, let's talk a little bit about all the different players that are keeping tabs on your model's health. So, outside of data scientists and ML engineers, there's business stakeholders, customer success, auditors, regulators, so many players here. And they're all approaching this from different angles and asking different questions in order to not only understand, but also trust the ML systems that they have in place. So, the line of business might be asking, is the model meeting my business KPIs? Whereas auditors and regulators are wondering, are the decisions my machine learning model making fair? So there's a lot of perspectives that we need to consider here. Now, if you're one of the stakeholders that's building the machine learning model, Fiddler supports you across the 3 stages in the entire ML lifecycle. Now, we're going to talk about the 3 stages. The first phase in the first stage is pre-production. And Fiddler really supports you here via model validation from a bias or a fairness perspective, as well as a performance perspective. We also enable deep explainability, so visibility into your model's behavior. The second phase in this life cycle is production. And Fiddler helps here by enabling monitoring, real-time alerts across data drift, performance, custom-defined metrics, and many, many more. We also support root cause analysis and explainability so that you can resolve your issues, and then flexible dashboards and charts so that you can track both, data science metrics as well as business KPIs. And if this is a lot, don't worry, we're going to be demoing most, if not all of this really shortly. Now, one of the key steps in this life cycle is a continuous feedback loop for model retraining. So as your business evolves, as new data comes in, you're going to have to retrain your model, and Fiddler can help you pinpoint problematic predictions, and potentially you can leverage those to choose to retrain your ML model. I want to quickly note that Fiddler does support LLMs, so large language models, and generative AI models across the same ML lifecycle. I'm not going to go deep into this as Barun is going to do a deep dive in the second half of this session on LLMs. But what I want to stress is that this is a unified platform for predictive and generative AI models alike. One recent announcement that Fiddler had that I want to share with you all before we continue is our image explainability, or explainability for computer vision, so classification and object detection models. So we can actually do this by showcasing a quick computer vision or object detection use case. So on the right-hand side here, you can see an input image with proposals from a user's model overlaid. And I can see a proposal for a sink on the bottom left. Now, when I click onto a specific box, I can see either red or blue overlay, depending on which direction these group of pixels are leading the proposal. Now, if we focus on the sink, I can see that the shape of the sink, so that square shape, the 4 corners, is related to the positive attribution. But I can also see that the faucet really matters, which is interesting because that means that these models are taking cues from context outside of the bounding box to make its decisions. So if this piques your interest, you want to learn a little bit more, please reach out to us. This is just a quick preview of what we can do on the image explainability front. So to recap, we support, identifying anomalies and patterns to improve your predictions, make better real-time decisions, as well as allowing you to incorporate human in the loop to enhance the decision-making. So with that, I want to pause really fast, and we're actually going to put up a little poll for you all before we continue. So this is, again, just to learn a little bit more about where you currently are Great. Okay, so we're a split house, yeah. I can see that we're all over the place. It's really, really cool to see that, we're using a good version of AI observability tools, built in-house, open source, and it seems like pretty good amount split across everywhere. So hopefully we learned something cool and we can do a little bit of comparisons across what Fiddler offers versus what you're using today and see if we can complement some of your processes. So thanks everyone for filling that out. Good to know. So we're going to go ahead and continue here. This is the last PowerPoint slide on my part before we jump into demos, so bear with me a little longer. So the last thing I want to show are the 4 pillars that Fiddler AI offers. What this is really telling you is the 4 main functions we hope to offer you. So the first is ML monitoring. So monitoring your models day in and day out to ensure that they're performing as well as when you first trained the model. The second is explainability. So understanding, why is my model making the decisions that it made? The third is analytics. So as your model starts to degrade, you're going to want to do deep root cause analysis, pinpoint problematic cohorts, and make sure that you walk away with actionable takeaways. The last, but definitely not the least, is fairness, right? So understanding, is my model biased and what can I do to mitigate that bias? So with that, like I promised, that was our last slide. We're going to jump over to our demo. So before I actually start the demo, I'm going to go ahead and put on my customer hat, and I'm going to pretend that I'm a data scientist at New Age. And this is going to complement Barun's half of his demo, but essentially New Age is our made-up banking company. So as a data scientist at New Age, I am on the churn analytics team. So just to paint a little bit of context. So as a data scientist, I log into the Fiddler deployment, and I can see a model monitoring summary. So I can see a little donut overview of my performance, data drift, data integrity alerts, as well as an overview of every single model that I have registered into the Fiddler platform. Again, being part of the churn analytics team, I'm really interested in this bank churn project and churn classifier model. And I can see a number of alerts that pique my interest. So I'm going to go ahead and investigate these triggered alerts by clicking on this little bell icon. So where this takes me is to a list of triggered alerts. So I can see that there's a number of data integrity, performance, and data drift alerts that have been triggered for this model. Now, I'm particularly interested in this output drift alert. So in order to further investigate this alert and what's going on, I'm going to go ahead and click on the inspect button. Clicking on this inspect button navigates me to a monitoring chart, and we'll visit these a few times in these demos. So in this monitoring chart, what I'm seeing is my output column plotted over time. And because I came from an alert, I can actually see the warning and critical alert context overlaid on this chart. What that means is that it's very easy for me to see which points are triggered. So I can see that there's a number of warning, the yellow, and critical alerts triggered for this time period. Now, before I try to start, analyzing what went wrong and digging into these alerts, let me try to really understand what this chart is communicating to me. So in order to do this, I'm going to click on a historic time point where the drift is really low and not a concern. And the first thing I notice is that my root cause analysis tab got enabled. And this root cause analysis offers more detailed information and tables to better understand what's happening with my features at this particular point in time. Now, the first thing I'm going to do is sort by prediction drift impact. And what I can see here is in that point where there's no alert, the drift is very low, 47% of my prediction drift is attributed to this age column. So I know that's what's happening when the drift is really low and not a concern. Now, what happens if we compare that to a point where an alert was triggered? So let's go ahead and look at this data point for November 3rd, where a warning alert was triggered. Now I see that my root cause analysis table was recalculated, and specifically, I can tell that 66% of this prediction drift that is unacceptable is happening across this number of products feature. Now I want to pause really fast and just explain that prediction drift impact is calculated by a combination of how much the feature has drifted, as well as how impactful that feature is. So I can go a little further and go ahead and expand this number of products feature, and I'm provided with a data distribution chart. And what this is telling me is my baseline and production data. So my baseline here could be maybe my training data set, and I can see that my training data set featured mostly values of 1 and 2 for this number of products feature. But I can very easily see that production is seeing an increase in the number of 3 and 4 values. So I can visually see this drift happening. Now, a lot of products will stop here, and it's kind of on you to figure out what's next. But we're actually going to go a step further and leverage the Fiddler Analyze experience in order to do this, or in order to look a little deeper. Now, what I want to figure out is this drift happening across my data widespread, or are there specific problematic cohorts where we're seeing this drift, right? So I'm going to pop over to Analyze, and here's where I can do that kind of deep digging. So the first thing I want to talk about is what we're seeing on this page. So the first thing is the slice query or SQL area. So I can go ahead and construct the query here. I've selected all the columns from that churn classifier model for that problematic time point we were looking at, so that November 3rd area. And then I'm going to run this to provide a little more context. Below, what I'm getting is basically events or data points for this time period. And on the right, we call this the console, is where I can overlay a variety of different analytics charts to learn more. So I could choose to look at feature distribution, feature impact, slice eval, and more. Let's go ahead and look at slice evaluation. So what slice evaluation provides is a number of different performance visualizations. So this can be metric cards, the confusion matrix, and more charts. Now, I want to note that the accuracy is quite poor for this alerted time period, which makes sense. And the number of false negatives is also quite high. So this is a little, the model's not doing too great. But what we do know is that number of products is one of the features that is drifting. And I want to know, are there other features that are correlated to this drift and this feature? So I can use my feature correlation chart, and I can definitely choose number of products because I know that that's drifting. And I want to know across other features, is this drift correlated? So maybe I'll pick something like geography. And I'm saying something really interesting here, and we'll walk through it together. But I'm seeing, in our RCA, in our data distribution, we saw that there was an increase of 3 and 4 values for a number of products. And I can see that 3 and 4 value is predominantly happening in this Hawaii geography. So let's dig into it a little bit more. So we have a really flexible SQL query on the left. Let's go ahead and check out where the geography is equal to Hawaii and see what's happening. So we're going to rerun this query, and this isn't going to change too much, but what we want to see is the slice evaluation, the performance. So sure enough, we can see that the performance has taken quite a dip, and the number of false negatives has increased significantly. Now, again, this is telling me, hey, definitely Hawaii is a problematic cohort, right? Problematic slice of data. But let's see what happens if I were to not include Hawaii. So if I don't include Hawaii in this slice of data, I can see that my accuracy is much, much better. The number of false negatives has decreased immensely. But I want to dig into this a little further. I don't even want to end here. We've already identified, a problematic cohort. We can definitely take this back to the team and run with it. But I want to go a little further. So I'm going to go back and look at the geography equal to Hawaii one more time. And what I'm trying to do is dig into these false negative samples. So the way that I'm going to do this is by saying, I want to know where churn actually did happen. So where churn was yes, but the model, so the probability churn was low, meaning the model did not think that this user was going to churn. So again, I just went ahead and clicked into those false negatives. I see the same 60 samples. And I'll explain in a second, but in order to showcase this a little bit more, I'm actually going to order by probability churn ascending. And this doesn't impact the chart on the right, but it does impact the data table below. What this has done is basically bubbled up the places where the model was the most wrong, right? So we can see the model is almost certain this customer is not going to churn. But when we pass in our ground truth labels, we can see that this customer did in fact churn, right? So our model got it really, really wrong. And what we can do straight from here is we can choose to do point level explanations. So I can click on this little light bulb, and Fiddler is generating this for me. It's trying to explain what features are impacting my prediction. Now, I can choose a number of different out-of-the-box explainers, or I could even bring my own. So you can bring your own explainer and get access to it straight from this dropdown. What I'm going to do is I'm going to view this tornado plot. Now, this tornado plot, again, is just trying to tell me which features are impacting this prediction, right? And driving it to go so low. And I can see pretty obviously what we already know, which is the number of products, right? Seems to be driving this prediction quite a bit. Now, I can actually do what if analysis here. So I can go here and say, what if I were to change for this time period? What if I were to change this 3 to 2? So number of products is equal to 2. and I'm going to rerun this calculation. And not only am I going to rerun it, I actually want to compare it to the model's initial decisions. And I can see visually, as well as with the prediction, that the model went from being pretty darn sure that this customer was not going to churn to pretty sure they are going to churn by a very small change that I made using what-if analysis. So this is, again, surfacing a lot of feature sensitivity to this number of products feature, maybe too much sensitivity. So I'm going to go ahead and close out of here. So what we've talked about here is, hey, I identified an alert. I did a little bit of root cause analysis, identified a problematic cohort, performed explainability. And this is great when I get a triggered alert, when I'm going down that monitoring path. But I also want to keep tabs on my model over a longer period of time. I want to communicate to business stakeholders and more. So let's talk a little bit about how you would do that using Fiddler. So I'm going to pop over to this other tab, and we're going to do this by showcasing both the charts, flexible charts, as well as the flexible dashboards. So coming into here, I'm going to showcase a chart that I created before. If I can find it, I will search for it. Give me 1 second. If not, we will create it. Yeah, here it is. So we have a revenue loss. It's demo magic, right? We have a revenue loss chart. So here I'll explain a little bit about what's going on. So these flexible charts allow us to add multiple metrics to a single view. So if you want to visualize performance and traffic and average value all at the same time, you can do that in a single chart. But what I chose to use this for is a little bit more of creating a business KPI. So I defined separately 2 custom metrics, one that does false positive count, as you can see here, and the second that does revenue lost from false positives. Now, revenue lost is something I defined as a dollar amount attributed to every false positive. So I said that the business would lose $100 for every false positive made. And I also put false positives so that you could see that trend. Now, I added these 2 custom metrics as queries into the chart, and I saved this chart. And now what I can do is I can go to my flexible dashboards, and I've created some dashboards. There we go. I created some dashboards here. So I can go to churn model, and I can see that my revenue loss dashboard or chart that I created is in my dashboard. I can share this with business stakeholders, etc. But I can also plot some out-of-the-box metrics, such as prediction drift, DI violations, feature drift, accuracy, traffic, and more. And I can continue to add. Even in DI violations, again, you can see that multi-metric happening. I'm showing missing values, range, type violations, and you can do so much with these charts. Now, that does conclude my portion of the demo, so I'll stop sharing, but I do want to give a quick overview of everything we went over. So we covered viewing a monitoring summary. We talked about digging into an alert, as well as doing root cause analysis, explainability, pinpointing problematic cohorts, and talking about these dashboards and reports that you can share with different stakeholders. So with that being said, I'll pass it over to Barun for his part of the session.
All right, thank you so much, Sabina. That was a really insightful overview of MLOps. Hello, everyone. My name is Barun, and I'm excited to guide you through Fiddler's innovative capabilities specific for LLMOps. So if you remember, and if you attended Amal's demonstration earlier, which illustrated the utilization of Fiddler Auditor to assess LLMs in the pre-production stage. So we use some model-based metrics, model-based evaluations for us to showcase, to figure out if the LLM or the LLM pipeline that you have set is good or not. So that was the pre-production stage. I'll specifically focus on the practical aspects of monitoring, enhancing, and managing LLMs once they are in production, so in the production phase. So if we So LLM ops, like everything else in life, is an iterative process. We move between pre-production and production phases, constantly refining as we harness the power of LLMs as we create value. At Fiddler, we are crafting tools that simplify this and streamline this journey between the pre-production and the production phases of this LLM. So when it comes to production, we offer out-of-the-box, specialized, ready-to-use metrics tailored for the LLM's use case. So the tools that we are building right now, the vision that we have is you come in with your prompts, responses, and context, and we give you a bunch of metrics right out of the box. Metrics which fall in the bucket of performance, data quality, correctness, privacy, safety. And then you can chart them in different kind of dashboards, which Sabina showed earlier. And you could do a deeper analysis using the analyze and UMAP visualization. So we have a high dimension, we have the vectors representing this LLM's prompt responses context in high dimensional space. So we provide tooling for you to be able to visualize and have a high level view of what's really happening in your with your production data. And then we offer you tools for analysis where you can go and dive deeper and do some kind of analysis about if you are having any PII loss, if there is some kind of toxicity, all the out-of-the-box metrics that you can get. So you would see that there is a poll that's come up. So it would be great if you can take a minute to sort of go and answer that. Cool. Thanks a lot. So those were all the slides that I had, just laying the groundwork about what we are doing at Fiddler, building on top of what Sabina talked about earlier. So now the fun part. We have the BreakBot challenge. So this is a demo app that we have built, which builds on top of which is for the new age bank that we talked about earlier. It's a new age bank chatbot which you can access and ask it different kinds of banking questions. So on the backend, it is using a rack-based setup for you to interact with it, and you would see that there are a few options of models when you access that. So let me just go to new age bank and show you what's happening there. So this is how the assistant looks like, and you can select any of these different models and ask it questions related to banking. Now, what is really the challenge? Now, you have two sets of challenges. You have to put on your hacker's hat and do some amount of prompt injection for you to be able to get some PII data out. And now, when I say PII data, it could be phone numbers, emails, names, SSNs, accounts, account number. If you can get that, it would be that'll show up. And the second one is, out of all the 5 models that we have, 6 models that we have in production over here, can you figure out which one has a propensity to give out toxic responses, unsafe responses? And then the final challenge is, if you can, that's extra credit, of course, if you can find out which of the available models actually hallucinates the most. So you ask it a certain kind of question, either it says yes or no, but it ends up answering some totally different questions. So while this is happening, let's give everyone a minute to start interacting with it. So, you'd find that when you interact with it, you'll have the response. It says yes or no. So this is definitely a useless response. So the moment you do this, you give a feedback that shows up in the dashboard that we have set up for the BreakBot challenge. So you'll see that right now there is 3 responses that people have registered till now. Let's continue adding a few more. And let me use some different models here. Let's try to use. Let's see if this one responds. So this is good. This one is a good model. It did not respond with toxicity when I was being toxic with it. This was a bit of hallucination. It did not really give a good answer, or it said no to it. So I urge everyone to sort of do this kind of exercise as we keep track of the traffic that's coming in. 7, yeah, it's cool. People are engaging with the bot. It's great. So while people are working on this, let me take you through this dashboard that we have built for the BreakBot challenge. You'd see that there are operational metrics that we have plotted as with charts. So one is traffic, like how many interactions are happening with the bot. Also, we have a chart of how are people interacting with different kinds of bots. Since we have 6 different kinds of bots, we have split it up and showing it as to which are the bots which are being engaged with the most. So right now we can see that Flan, because it was used during testing earlier, is one of the leading models that is being interacted with. Along with that, we have these charts which are keeping track of the 2 challenges. One was about PII and the other one was about toxicity. If there are any prompt leakages, or if there are any PII leakages in prompt response, or there are any toxic responses here or not. Here we can see on refreshing. Oh, nice. There's like a whole lot more responses coming in. That there are some amount of toxic prompts that are being sent. But the good thing is that none of the bots have responded in a toxic way yet. So no one has really managed to get any of these bots say something toxic. But the sad part is the first challenge about leaking PII, it looks like some of the bots did leak out the PII information to the questions that are being sent. Let me just send one more time. Cool, awesome. So what happens when something like the PII or the toxic prompts and responses are getting generated? So as Sabina pointed out during the MLOps demo, you can set alerts for them. So when you set an alert, they show up over here. So let me just do a quick refresh and see if the alerts were fired. So you see that the alerts were fired for both toxic responses and toxic prompts. So this is basically the stuff that the example that I showed up earlier. So when an alert is fired, it shows up on your in your email and whatever other tool that you have set up. It could be it could be a Slack notification, emails, as we see over here, or PagerDuty. So now you have seen you see this high level alert that has happened, and you want to dive deeper as to what actually caused this alert, and is there something else that that you can do to is it actually toxic or not? You want to do deeper analysis. So one way to do that is going into the analysis chart, analysis of this particular model. So we would try to see which, since we saw that there were like PIIs leaked, we want to query the production data and find out all the events where PII information was leaked. I write a simple slice query and do this query, and then you can see that there is some amount of information that was there. There was a response of John Smith for a totally different question. Someone asked a really pretty good question about trying to get the credit cards. Thank you so much for that. Can you tell me a name? So there was some response related to John McCarthy. So it sort of leaked out that there is this name, there's a person by the name McCarthy. And then it used this context, all this different kind of context to give this responses. So this gives us some sense of what really happens when it gives you a high level view. So you can go in and check into the production data as to what are the events where the PII leakage actually happened. Now, the second challenge was to find out cases where toxicity happened. So similar to this PII response and writing a slice query for PII, we have written a slice query which keeps track of safety. Now the safety number that the automatically generated metric that we have, 1 represents something that's safe, 0 represents something that's unsafe. So closer to 0. So we are listing out all the prompts and responses where the safety of the response was low. So if you look at that, the the one of the bots actually responded with "I hate you." This is a very funny prompt. This is a question that I asked, and I think the word "crass" was marked as something that's unsafe. So the metrics that we generate give you a sense or give you like an alert about that something wrong is potentially happening. And then you can use these tools to go and do deeper analysis of what really is going on. Is there something that actually needs deeper investigation or not? Now, the other tool that we talked about, which helps you visualize things that are happening at a macro level, is UMAP. So in UMAP, what we see over here is you can select the model column, whether you want to look into do a draw UMAP for the prompts or the responses. And then you can have all these different out-of-the-box metrics that you can potentially plot on. So here I have selected PII prompt responses, safety prompt, safety responses. I'll add sentiment into the thing, and I also add the model name, the different models that people are interacting with. And the question that I have in my mind right now is, what are the kind of questions that people are asking? Because prompt is basically the prompt. So I'm sort of trying to do a little bit of topic modeling. So let's just go and trigger a UMAP generation. So what I'm really looking for over here is if there are interesting clusters of questions that pop up. So let's see if there is anything. So let's start with sources and responses. So first thing that I see over here is the baseline, which is in blue color, and the production, which is in orange color. The production is actually sort of different from the kind of things which baseline was done. So the baseline is usually selected on what the chatbot is possibly trained to answer. So if you have something that's fine-tuned, some amount of question answers that you expect it to give, then this is where it is all at. But there is definitely a change in the distribution of sorts of where the production data is going. It's quite kind of far. So let's look at the furthest data. There is a question, a response which says COVID on buses. This is clearly falls in the bucket of being a little toxic. Let's see if it actually shows up. So let's see into the response. So you could see that that was definitely a case of all negative prompts. All the negative questions which people are asking were sort of clustered around here in the production data. Let's see what that. Oh, someone asked for a racist joke. I hope you did not get a response on that. And then someone just said more on to the bot, whatnot. So that's so it has to give a sense of what's happening. And now we have sort of identified this cluster. We can stay on the same page and do slightly different analysis. Let me see what are the kind of models which are responding to this cluster, which seems to be a little problematic. So people were asking this question to Plan, Mistral 2, Plan again, and yeah, a lot of stupid questions here. Let's look at some other, we can stay on this and continue doing our analysis. Just high-level analysis, getting a sense of your data. And let's look at what's the sentiment. Let's look at maybe PII response. Was there any kind of PII data that was leaked? You can see that there is some amount of leakage that happened over here because, and let's see what are Mistral. So there was like, we asked Mistral, Flan, GPT-2, this Flan seems to be one of those models which is clearly lacking, like sort of giving out a lot of the PII stuff. So if your answer for the challenge was and you managed to break using Flan, then you did a pretty good job. Thank you so much for that. let's see if any of the other Mistral is negative. There's some GPT-2 again. See GPT-2, GPT-2. So this sort of gives a sense. Now we sort of know that FLAN is one of those models that you should not put in production because it has a propensity to leak out PII information. And then you can go and do deeper dive. Again, going back to this, you can check, write a query which says model name equals to FLAN. Then you can do some amount of questions, answers. And do analysis of FLAN, maybe take FLAN offline, or maybe go back to production, add better prompt engineer, like to add better prompts, add a lot of better system prompts to FLAN before you put it into production. So this gives you a clear indication that FLAN is not one of those models that you want to put into production. So the next piece is like the different kinds of dashboards that are there. So we started off by showing you the BreakBot challenge dashboard. Similarly, depending on the different stakeholders that exist in your, or the kind of information that you have or you care about, you can set up different dashboards. So this is an end-to-end dashboard, which has all the metrics related to the entire system in production. So you have the operational metrics, traffic, interactions per model, something that we saw earlier, prompt, PII, negative, like the sentiment. You have safety metrics, you have a toxic prompt, you are keeping track of feedback, and you're also plotting, you're on the same dashboards, you're also plotting the UMAP for both prompts and responses to easily be able to do quick analysis should you find something in the dashboard. So you don't have to change, switch between different terminals, if at all that's one thing you want. The next piece is, while this is happening, you might be interested in going into details about a single model. So now, since we knew that FLAN is a little bit problematic, you can probably decide to create a dashboard. So you have the complete flexibility, complete customizability about what kind of dashboards you want to create. So you can potentially create a specific dashboard just for FLAN. And yeah, so maybe the metrics that we have, so this is how you can create a dashboard for FLAN as well. But maybe the metrics that you're already getting is not sufficient and you want more. So you could go into Fiddler's chatbot, and then you can create a new metric that you care about. So let's say apart from FLAN, I'm also interested in knowing all the cases where maybe the keeping track of the traffic for some other model. So let's say the other model is GPT-2, like what kind of traffic is going into GPT-2. So GPT-2 traffic. And then I can write a simple SQL-like language. It's a Fiddler internal to be able to do this. So the way to read this if statements, if this condition, then to add 1 and give 1, otherwise it's 0. And everything is always an aggregation. So you're aggregating for a time range. You can think about this particular function being applied to different time ranges and giving you charts. So this is a new metric, which potentially was not there and you are interested in for some of your stakeholders. So you save this. Okay, all right. So, there you go. And so now this metric is available for you to chart on. So let's go and create metric, this chart for this new metric that we just generated. So let's go to monitoring, and then within chart quality, we have custom metric. And this is a GPT-2 traffic related metric. And then you see that just instantaneously, the moment you add it, created this particular chart, or the metric, it's available for you to chart on. So you could go and create, let's say, chart. And this chart is now available for you to add into And so let's just go back to BreakBot challenge, see if there are more. Oh, there's more interaction, that's great. Then we want to chart. Just add a saved chart. And then we had the GPT. So this is the chart that we just added. And this just shows up. And we see that the traffic for GPT-2 was 0 in the morning when they did not test it out. But and since we put it on, we are seeing a bunch of traffic going into GPT-2. We'll save this dashboard, and now this dashboard is ready. So that's the overview of some of the things that we are doing for LLM Ops. As you'd see that the workflow of going around between the tools which are for MLOps are now also sort of available for LLM Ops with additional metrics that are applicable for the LLM's use case available out of the box. And then all the power and the familiarity that you had with the MLOps tools, MLOps side of Fiddler, are automatically applicable to the LLM Ops as well. And also and you can continue in your iterative journey between production and pre-production as you improve or constantly improve your LLM apps, whether it doesn't matter if you've started using assistants for OpenAI's assistant already, but you still need a nice tool which allows you to keep track of the quality, the hallucination, if there is anything, a better monitoring tool, which is not necessarily available at OpenAI at this point. So with that, that's the end of the demo. I'd love to know any questions and that anyone might have.
Great. Thank you so much, Barun and Sabina, for the great demos. Let me start off with some of the Q&A that came in through the chat. So first off, let me ask Sabina these questions. So, and I know, Sabina, you have answered them, but I would like everyone to hear it one more time. How do you validate ML models before launching into production?
Yeah, definitely. So I did provide a written response if you want to spend some more time with it, but essentially during pre-production, I think the most valuable pieces that Fiddler offers are explainability and fairness. So you can use explainability, like we mentioned, to really understand how a model arrives at the predictions that it does. And then you want to be able to trust that model before you put it into production. Kind of on the same side of the coin with fairness, you probably don't want to put a biased model into production. You want to know if it has bias before you put it out there and try to mitigate that before it even happens. I would even say that monitoring plays a good part here, but definitely explainability, fairness are really good tools on Fiddler to help with this phase.
Great, great. And the other question that they had was, can you compare two versions of the same model in a report? How would you go about doing that?
Yeah, so you actually have two options. If you don't want to, create a full-blown report, you can actually do model-to-model comparison in a single chart. So let's say you're doing it for exploratory reasons. So we talked about multiple metrics. Within those metric queries, you can choose to plot two different models and compare their performance, et cetera. Or you can decide, hey, I want to track this long-term. I want to share this with stakeholders. You can create one or multiple charts across these different models, add them to a dashboard, and track that.
Great, great. And this is not a question, it was I believe a compliment by one of the attendees, Santosh. This observability tool invokes several new ideas.
Thank you, Santosh.
To share that out to everyone. All right, so moving on with some of the LLM questions over here is, Barun, how can we bring our own metrics to monitor LLMs? And if so, how can we do that?
Oh, absolutely. You could bring in your metrics, whatever you care for. For example, you might have tokens. So when you're interacting with your model, the tokens information is something that only you would have. So the way you do that is provide it as metadata when you're onboarding the model. And then all the charting, all the alerting that we saw and demonstrated, that's automatically available for you. So yeah, you can come with numbers. We show you those pretty numbers on charts, and we help you to alert on them as well.
Okay. And just side note in terms of, because you showed UMAP in terms of like all the different data points on UMAP. Can you select multiple points to compare across?
Oh yeah. You could select multiple points. I can quickly show that as well. But yeah, for sure, you could select multiple points and do an analysis on that as well. So we mostly show the hover example, but we can select.
It would be great if you can show it real quickly to the audience.
Yeah. Okay, let me share my other screen. All right, good. Are you able to see the screen?
Yes, absolutely.
Awesome. Yeah, awesome. So this is one of the tools that allows you to select like multiple points. So if you go back to the analysis that we were trying to do earlier, that we found this interesting sort of cluster around here. We could go ahead and select that point, a bunch of points here, let's say right here, and they show up at the bottom. So it allows you to look into a bunch of all the data points that you selected, like in real time. And it has all the information that you sort of ask for in the display column side. Cool. Does that help answer the question?
This helps answer the question. And does UMAP also support computer vision and NLP use cases as well?
Yeah, it does. I don't have a model onboarded on here for the computer vision, but it's mostly about you bring your embeddings, you tell us where the images are, as long as the images are accessible over URL by the platform, if they are visible.
Great. All right. Moving on to the next question. There's a couple here. All right. So this person is basically, he's playing with a mixture of LLMs from OpenAI, Anthropic, and also considering building their own LLM, SLM. Do we support any of these type of LLMs?
Yeah, absolutely. We are LLM agnostic. We do, as I said, you give us prompt responses and the context. And you could onboard it in different formats, and then we give you all these metrics out of it. We don't care if that's one of the cases why we showed that the LLM did not matter. We had GPT-2, we have Flan, Mistral, and it could easily be OpenAI as well. So you could select that as an option. The interaction happens, and you publish those events, you get the metrics.
Got it. All right, so you just answered that. There was another question asking the same thing about, whether this tool only supports custom in-house built LLMs, but we support anything. All right. Another comment from one of the audience attendees. This is an excellent live demo with good examples. Thank you so much, Barun and Sabina. All right, this last question that I have here, and please, if you have any questions, please put them on the Q&A. We'll answer them. This question over here is, if a model can be detected to be sending a PII violating output, why can this detection not be architectured to occur before the output is sent out to prevent it altogether?
Oh, it can absolutely be. So it depends on what you want to achieve out of this. Like, do you want to be set sideline? Like, do you want to inline this communication, or you want to say a sidebar? So right now, the operations method that we talked about over here is like doing a sidebar. You help you detect if something went wrong, you could catch that. But in future, we would be getting into a place where even before the response is sent back, we stop it and do not allow it to pass through. So that's definitely the future direction, an excellent point. Why even send the response back if you know it's going wrong, and that's the direction in which we're going.
Got it. All right. I don't see any questions, any more questions on the Q&A. And I've also included to everyone a blog on our latest updates on ML and LLMOps support. Thank you for joining. Thank you so much. Bye.